Okay, you hear me? Good, 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 good. Wow, a lot of people. So I'm really happy to be here, like for the first meetup we organized for the Go community. I heard we wanted to do a Go community like a year ago, and I wouldn't expect to have like so many people here. So thanks for coming. It's very nice. Let's try to keep this simple, like informal. If you have questions, if you don't understand something when I'm speaking, you can interrupt me. And I'll try like to maybe explain again or yeah, make sure we understand each other. So Go features I can't live without. Before we start, I wanted to make a survey, ask some questions that actually together with Honza, like we wanted to understand better the community. So I want to understand from you guys, like who is not from Brno? Is there somebody coming? Like who doesn't live? Okay, I'm also not from Brno. Like who doesn't live in Brno, work here? Is there people that came like 4 in the morning, had to travel? Okay, so not so many people. We have a lot of foreigners, or a lot of people that are not from Brno, but not so many people coming from abroad. So how about people who never wrote a single line of Go? So beginners or, okay, good. So it's good that the first talk will be like, there will be a little of code, but enough that you don't have to worry. You don't have to be a Go professional to understand it. And who here actually writes Go frequently? Okay. So I imagine all the rest is in the middle, like has worked, has done something with Go, or is just not paying attention, maybe? Is that the case? Okay. Hans, I'm going to close your computer, too much light here. Okay, so we know more or less the public, right? We have a lot of foreigners. We have some people that are coming from other cities. Thanks for the extra effort to come. So a few people use Go every day, few people doesn't. I'm one of them that use Go almost every day now. So this talk, I don't want to like brag about myself, but I want to find like, okay, when was the first time I actually got in contact with Go? And I try to do some research on my email, try to remember. And this is just like some facts that I found a chat message on my history like in 2011, and that was before Go 1. And I can't understand like why I was chatting about Go at the time. It actually just started, like, and over time, like I hear about Go, probably like most of you like heard about Go somehow. And it was only in 2013 that I wrote 2 projects. I was living in China at the time, and I wrote this project called Shemetzi, which is a Chinese dictionary, actually Chinese to English. And that was my first project in Go. So I was like, yeah, let's try it out and let's see how it goes. Then time passed, and now since last year I'm working on OpenShift for Red Hat. So it's been over a year now, over a year in Brno. So in this talk, as I said, it doesn't require a lot of knowledge about Go. It may serve as some introduction to Go, but it's not perfect. Right, it is not the focus of the talk, so I suggest there is a link, like later I'll post my presentation, there's a link to the tour of Go. That's probably the first place you start to get a feeling of the language. You can type some code in the browser and like, see how the compile it and run it, see what happens. I will actually talk about features that I enjoy personally, so it's very opinionated, like as with time, like I realized that there are some things in Go that makes it really cool. And whenever I'm working on a different language, I'm like, it doesn't have this. So let's start. First thing is actually not about features, it's about the lack of them. So that's, if you have to remember one thing about what I say today is that Go has not a lot of features. And it's really in the simplicity of it that for me is the most interesting part. And like each of these bullets here, I try to like put as a reminder for myself to tell some story. So the first one is to say that less is more. And what happens is that I'm generally, I like to learn about languages, so both spoken languages and programming languages. So like recently I can think of some examples like F#, Rust, maybe D. Like I hear about these languages and I go look at the documentation, try to see like how the language is like, what do I have to learn, and normally the language specification is gigantic. Like, who has ever found this problem? Like you want to learn something, and okay, the entry level is like, okay, read this book, or like, yeah. So do you guys like feel the same? Yeah. So that was cool. Like when you go look at Go, like I did go to make a comparison. Like I think F# was a document. They released the language specification as a Word document. So like pretty weird. And if you want to submit a pull request, you actually go change the Word document and send a pull request. So that was really weird. And it's like 400 pages, I don't know. And for Go, like I try to print as PDF, the language specification, and it goes about like 40 pages. It's not a fair comparison to talk about like number of pages. The content of the documents is not actually the same. But I feel like it gives a pretty good idea that with Go, you don't need to go through a lot of documentation before you can be productive. It's a really small language. So because it's small, it fits your brain. It was the same feeling I had with Python. So I've been doing a lot of Python before. Who here is a Pythonista? Yeah, we have some. Rubyist? Less? Maybe Java? Okay, I kind of fills the gap, okay. So yeah, there are a lot of Pythonistas. Like a lot of things that I like in Go, actually, they are, let's say, improvements of what I already liked in Python. So this fits your brain is one of them. Like learning Go, like you don't have to like all the time go look at the manual. You just learn these little things and okay, that's it. Things that seem or should work as you imagine they should work, they just do. And like there are little surprises. So because it's small, because it fits your brain, I would say it's easy to learn, and there's like nothing spectacular. It's easy to learn because there's nothing new. If you've done any language that is the Fortran style of languages, so C, Java, Python, you'll be reading Go in the first day, right? You see, for those who never saw Go, like you will see today that there'll be some code. So it just looks right? There's no surprises. So it's easy to read. I'll skip this. It's suitable for larger teams. So why do I think this is pretty cool? The OpenShift team has tens of developers working, a lot of pull requests coming concurrently, and you know, you can't expect that all of these people working on the project, they were Go experts. They were born with Go 1.0 and they know everything. We are not perfect, right? We make mistakes, and I feel like Go is a good language for you to maybe make mistakes because there are less things for you to like invent, right? If the feature set is smaller, you just use what is there, and so like bigger teams can be more successful, I would think. So the other one is other languages compete at feature set. So there's this very interesting talk. I put the link here from Rob Pike. He's one of the creators of Go, where he discusses simplicity of Go and why he also thinks that's an important feature, and how it's complicated to achieve simplicity. And in the beginning, like he discusses how other languages are becoming the same, and I really felt like he may have some reason to say it. Oh, is it gonna die? I need her help. Thank you. So yeah, the point is that every other language that we know, they're competing on features. So if you see a new version of JavaScript, it's got all the new features from all the other languages. So it's got like new syntax, new ways to create classes and stuff, right? If you look at Java 8, it's also like growing. Like all languages are growing and they are becoming the same, right? And they're competing on features. Go chose that after Go 1.0, they're not changing the language. So it's only those features and that's it. Like you like it or not, that's what you get with Go. So let's move on. So the language that have a lot of features, this is my highlights from that talk from Rob, is that if you have a lot of features, then you have to choose which ones to use. If you have to choose which feature to use, it means like you have to learn more, make decisions about, oh, am I going to create an abstract class or something else? And you end up like making your life later harder, right? When you have to read your code, you think, okay, why did I do this here and not use this other feature? And also other people may have more trouble understand your code. And I think this is just a waste. Like it's harder to maintain later on. So I really like that, like the fact that there are less features, you don't have to ask, should I do this or that? And again, comparing to Python, we are in the same Zen of Python style that there should be one way and only one way to do something, right? One and only one obvious way to do something. And different than Perl that says, okay, there should be always a million ways to do the same thing. So I like that. The trade-off is, do you want a language that is fun, like Ruby, that you can do everything, or like very dynamic, lets you write DSLs and new syntax, or do you want a language that is productive, that don't get in your way? And Go is not for everything, but if you want to do certain things, I would say that that's the language. So for like writing web servers or system like OpenShift with a platform as a service, it's really cool to have a language that is boring, right? And there's another talk here with the link, which is a talk from another guy from the Go team, where he explains like why Go is boring. And it's basically like since the Go 1.0 was released in 2012 or 13, I don't remember now, there are no new features to the language, and the changes are asymptotically decreasing. Like so, you don't expect anything new to come into the language. There are just improvements to speed, to garbage collection, and other things like that. So there won't be new features. So you can call that Go is really boring. Like you look at it, there's nothing new. There's nothing that other languages don't have. It's just that, right? And so again, simplicity. I really like it. Let's go to the second point. There will be 8 points, by the way, so you can say like, oh, like, is it near the end? Is it not? So again, like if you have any question, comments you want to make, like just raise your hand and we can, I think, do it right on spot. I think I have about like more, 20 minutes. I don't know. You can tell me, right? Honza, tell me if time is short. So another feature is, and this is, I think, related to the simplicity, a single dispatch. So I was reading recently about this language called Julia, which is, it tries to kind of replace Python for scientific computing. So it's like competing with Python, R, MATLAB. And like right on the homepage, they're saying like, yeah, the most exciting feature about Julia is multiple dispatch. What it means is that you can have a function that, depending on the argument types, it has different implementations. So I thought like, yeah, that's cool, but what does it really mean? It means that for me, when you're reading the code and you see a function, you cannot tell like what exactly that function is or what it will do unless you know the types of the arguments. And you kind of play a bit a role of the compiler and say, okay, you can't just go and grab the code and find the function name and say, yeah, this is the function that it's doing. So imagine you're debugging a code that you didn't write. Somebody wrote that very ugly code that you have no idea what it does and why it does that. And like now you have to figure out where is actually the function you should put that debug line or something. So I really like Go decide to have single dispatch. It means if you see a function name somewhere, you know, like there must be only one place for you to look, see what the implementation is. So there's no operator overloading, so you cannot change what the plus sign does or something like that. For me, it's also very good, right? Imagine you see code that summing two numbers means multiplication, or like, this is very weird. I think this happens a lot. I didn't get to write a lot of Ruby code, but I see this with Rails, right? Rails changed the way Ruby works. And then if you're working on a project that uses Rails, magically strings have some methods or have some behavior that without Rails, you don't get that. So here like feels or felt this pain before, like of being surprised by nobody. Yeah, so maybe I'm the only one. I'm a bit crazy. So yeah, I really don't like this magic. I prefer the language to be simple and that I am on control of what is happening. So there is one thing that people complain a lot about Go is that there are no generics. So because of single dispatch, because there's no way for you to have some function that takes multiple different types of argument, you cannot have, for example, a function that computes the max between two numbers, right? And people are like complaining, oh, like why you can do this in Go, right? If I have A and B, I want to tell if A is greater than B. But yeah, right, what you have to do in Go, you have to write this for integers, for floats, and so on. Like you have to write it yourself. And the reason it's not in Go yet is because the creator said, yeah, we don't know yet how to do it in a nice way, in a nice, simple way. So we prefer not to do it. So again, I like this approach of saying, hey, we understand this might be a nice stuff, but we don't know how to do it yet. So like, it's better to omit than to add something that will just complicate people's lives later. So here's an example that I stole from the Julia documentation. And it explains a bit like what is multiple dispatch, and then it goes to show all of the implementations of the plus method. They call it method. So like I cannot paste the list here, like 139 implementations of plus. And like, okay, so, and that's for plus, right? And maybe if you're writing, you'll probably be working with like code, again, of somebody else, and like if you have to debug it, maybe it's fun to write. I can see the point of being able to maybe explain the compiler that there's an optimized way of doing something for different types, but I would prefer to just give a different name to the method or to the function. Do you agree? No? You're so shy. Yeah. So here's an example in Go. So this is the first time we see some Go code. Who here is scared? Scream if you're scared. Okay, so we are good. So I just, oh, somebody scared? No? So I just, probably it's visible here. I'm trying to find, I think it's this, yeah. So I highlighted here one line just to show that whenever you see, like there's a lot of code here, but when you see a method called read, you know where it comes from. So there's no doubt if you look for you're just gonna look at what is the scheme reader and you look for the read method and there's only one. It doesn't depend on like, sorry, I think I almost made somebody blind with this. So yeah, there's no dependence. Like it doesn't matter what URL is, right? And if there are like more arguments, you don't have to do some crazy like compilation in your head. So I like that it's really grep friendly. So you can just, yeah, you want to find something, yeah, you can grep it, and wherever you find it, great, right? You don't need a special debugger or something complicated. So another point, very interesting. I'm always making mistakes now when I type Python code or some other code in other languages, is that capitalization in Go is meaningful. So what does that mean? It means that they found a way to make your uppercase and lowercase letters do something useful. So the way it works is that for things like function names, methods, types, variables, things that you like use identifiers for, right? So things that you declare that start with an uppercase letter, they will be automatically exported, which means you can use that from different packages, from outside package. And if you have it called lowercase, you mean that this is something private, right? So for me, this is like very, very nice stuff. Like you don't need to have a separate keyword, private, public. You don't need some implicit rules of like something by default is private or something by default is public. I think different languages treat these things differently if you omit a keyword. So I find it really nice that when I'm reading code, for example here, right, we had some code here. We can automatically tell that this method here is exported because it starts with capital R, right? But this type here, this is the type is a type that I'm writing a method on this type. It starts with lowercase d, so it's an internal type. It's not exposed. So if I'm in a separate package, I cannot call this. I don't have access to this type, but I could call this method if I had. So this is actually a bit funny, right? The method itself is exported, but the type is not. So in fact, if you can't access the type, you can't access the method. So this is some actual source code I was dealing with the other day, and I took from a project that is part of OpenShift. So yeah, this I actually had the example again. So next one, this again shows my roots as a Pythonista. So who here knows what is PEP8 in Python? Okay, almost all of you, great. Who likes that? Okay, yeah. So I think my life before that was always, even with PEP8, like it was always bad because I have some OCD, I think. Right? And whenever I'm reading code, if there is inconsistencies, they jump into my eye, and I get really crazy about them. So yeah, I was always puzzled, like, okay, learning C, should I put the curly braces in the end of the line or in the new line? And this is just a waste of time, right? I don't really care if it's here or there. I would just care that they're consistently placed in the same place, right? And where it is, I don't care. And what happens is that for most languages, all languages, it's really a big mess. Sometimes you have a company-wide style guide. Sometimes your IDE can help. But from my experience, it's normally a mess. And Python, there was this really nice idea to say, let's standardize the way you format your code, the way you organize your code. And then appears this thing called PEP8. So we are not here to talk about PEP8. PEP8 is awesome, but then goes a bit further and gives you a program that, given whatever source code, it prints the way the code should be formatted, organized. Yeah.
So that's auto PEP8.
Yeah. And when did auto PEP8 appear?
I'm not sure.
Yeah. So yeah, exactly. So I think this auto PEP8 and like there are a lot of tools in Python now. They're, I think, backporting the idea of making PEP8 like enforced automatically. But there is a problem with PEP8 because there are a lot of, so PEP8 is a document, right? You can go to a web page and read the document, and it's not like in a lot of parts. It's really like, oh, it's up to you to decide, right? There are like a couple of different ways that are acceptable. It doesn't enforce like a single way, and again, that's, you know, as the Python philosophy says, there should be one way. And with PEP8, there are not always a single way to do it. Like, so multiple ways are accepted. I don't know, like PEP8, if it chooses randomly one, I actually don't know what it does. But with Go, like, you don't have any of these problems. You just, whatever this program Go thumped, whatever it returns, that's the way your code should be formatted. So no more wondering where to put what, how many spaces, if it's tabs or spaces, whatever. Right? You just pass your code through this. You can, of course, configure your editor that whenever you save a file, it's already Go formatted. So no more discussion, no more time wasted with like code inconsistency. So with OpenShift, we have actually this on our CI system. So whenever somebody sends a pull request, it checks that like all the files are properly formatted following the standard. And why it's important that it's something that comes from the language. For me, there's another story related to JavaScript. So Python had PEP 8, I think, since it's PEP 8, right? It's from the very beginning. It's one of the first things that came in the language. And this really shaped the community to try to follow that pattern. With Go, it's a tool that is, again, part of the language, and it's very hard to find Go code that is not properly formatted. So I found recently, like trying to find some new add-ons for my editor, that there is a standard for JavaScript code. And the standard is called standard. And it's on GitHub under somebody's name. So it's like some username / standard. Great. You can install, like, for example, there are plugins for Atom to format your code using that standard. The standard is very opinionated. The guy chose, like, oh, I think it can be like this, that. And then on the same plugin, there is something called semi-standard, which is the standard, but now with semicolons. So what standard is that, right? And then there's a third one, which is called happiness. Yeah, happiness, why not, right? We should be happy. And happiness is, again, the guy that forked the semi-standard and said, no, but I want it to be with this, and that, because it makes me happy. And so, so I think, yeah, there's no standard. So the fact that it didn't grow with the language, like I think all of the other languages that we have today, they are in disadvantage. It would be very hard to say, hey, like, forget all the code that has been written, and now there will be a new way to format your code, right? So this was easy to put in the inception of the language, so Go was fortunate about it. So Go is really recognized for tooling. So there are other tools like GoFumped that are really useful and they are cool to have, but in this case, they're particular to Go. So there's this one Go fix that allows you to change Go code. It was really useful before the 1.0 release. So when there are breaking changes to the language, it helps you migrate code. Very similar to Python's 2.3, at least in the idea. There is GoVet for finding common mistakes in your code. And there are a lot of linters. There is a link here for a tool that is called Go Meta Linter that actually it tries to use tens of other linters for Go and unify the output. So yeah, if you add this to your project, you're gonna get for the rest of your life a lot of warnings of linters. So maybe not a great idea. But it's good to understand, like it can help you, especially GoVet can help you find really interesting mistakes that are easy to pass by. So another one, I have a friend here from documentation team in Red Hat. And I said I would mention him because he said that just recently he heard people saying that they want documentation to be something that you can't live without. So as the title of the talk was, the Go features I can't live without, one of them is actually related to documentation. There's another command on Go. It comes pre-installed when you install Go. It's called GoDoc. And it plays different purposes. So one of them is to extract, generate, and serve documentation. And so the cool thing is that the documentation lives with the code. And you can see here an example. This is a function definition from the standard library. I should try to use this, right? It's from the standard library. And the documentation is just plain text as a comment here. So again, similarities with Python, docstrings, yeah, that's familiar, right? So, and this is something that it generates. It can generate output for the command line. This is an example in the command line. It can reformat this to fit the line beautifully. You can also use this as a web application. So you start it and tell the port where it should be running, and it will serve a beautiful HTML documentation, just like you get on the official documentation for Go. You can get for your own packages. So this is pretty nice. And again, because this is part of the language, it's part of the official tooling, I feel like the culture of documenting Go code is really, really good. So, like, again, I work on an open source project in Go. Like, most of the code is properly documented. So it makes it really easier to maintain. Of course, not perfect. Of course, you know, we are humans. We sometimes don't have time or forget. But the culture around it of going and writing proper documentation for your, at least for the public interface you have, is really good. So I like it. And there is this website here, godoc.org, that actually lets you see the documentation for any package. It can fetch packages from GitHub, for example. So if you do like godoc.org/github.com/my-name/my-project, it will show the documentation for your project. So you can tell your friends, yeah, go see the docs. Yeah, so again, like some other languages have these, but not every language. So whenever I'm working on a language that is poorly documented or is very hard to generate good documentation, I really miss this. We are approaching the end, right? So point 6, no exceptions. And the funny story here, I will talk about the Czech language. So I'm not Czech, and I'm trying to learn Czech. And, and of course, so maybe some of you here are also taking Czech lessons. Who is taking Czech lessons like me? Okay, so you understand me, right? I go to class and the teacher explains, okay, there is this thing here. And, well, yeah, now here are the exceptions. And the exceptions outnumber the rule. And there is no way to, like, I always try to, you know, make my own rules and try to, no. So there are a lot of exceptions. But yeah, Portuguese is not very different in that aspect. There are a lot of rules, and then, like, for the common stuff, there are a lot of exceptions. And you're, like, puzzled. Why there is no, like, symmetry and, like, this perfect world that I'm looking for. So in Go, there are no exceptions. So again, for me, this is nice. This is the world I was looking for, no exceptions. But what does it mean for us, like, programming? Maybe you're used to raising exceptions and using that as a control flow in your favorite language. But yeah, whenever I see that now, I feel like maybe there should be a different way. So the way it works in Go is that there are no exceptions, there's no try-catch. Errors are just values that you can use all of the normal language things, all the language constructs that you would use for a variable, like a number or a string, you can use for errors. Right? So there are no magic behind errors, they are just values. Again, a link for an interesting talk you may look into. So I feel that, like, for example, again, like some bad stories, when I had to write some Java code, which fortunately was not a lot, I remember that in Java you have to, like, if you have if your method can raise an exception, you have to declare it explicitly, right? So normally you have like a method declaration, then you say it throws some exception. And then if some method that you call within your method also throws an exception, and you maybe don't want to handle that, you also have to add that to the list. And the list keeps growing, And there is an exception to this rule of having to declare the exceptions, is that if you have a runtime exception, you don't need to declare it. And, well, so what I saw in a project I was working on is that every exception was a runtime exception. So now when you, like, an exception can appear anywhere in your code and you have no idea, like, what's going on. So that was not very fun. Yeah, so I think that this is what like error handling will look like for a lot of people in Go, and they're really like scared about it. That you write some line that do something, and then the next line is if the error is not new, then you do something with the error. And then you do it again, and then you do it again, you do it again. And people are complaining like, oh, can you make this different? And like, I don't like a lot of error handling in my code. But for me, personally, I think this is really playing fair. And what we used to do like in Python or like in other language where apparently there's no error handling or no need for error handling is that we simply ignore them, right? And we say, yeah, this is, okay, it's never going to happen. And maybe, maybe in production when a user complains, like I'll go fix it. So I think like when you actually, for every line you write, you think what things can happen and what are all the cases that you have in your code. I think that's like really playing fair, right? And being more an engineer in the sense of engineering. Like you don't just build a bridge and say, yeah, maybe if there is an exception, right? Yeah, this is actually what happens in Rio. I don't know if you're following the news. There was recently they built a bicycle path along the coast. And suddenly a wave came and took it away, like boom, no more bike path, killed 2 people. Like, so imagine, like, no, I want to write like, I want to be fair about the code I write. I want to like look at the like handle the errors as they happen, not somewhere else. And for those people that actually complain about this, oh, they're error all the time. What normally we are missing is that we can actually program the errors. So the fact that they're just normal values, we can use all the language stuff to make the handling more smart or more reasonable to read. So this is one example that this is the final, like the bottom part is how the code would look like if we just wrote some code to make error handling better. You write your method call sequentially, and only in the end you check for the error. Because what you did is you create some functionality here that it allows you to store an error as soon as it occurs. Every time you call the method again and there is an error, it's a no operation. So it will just do nothing, right? So for example, if there is an error on the first line here, on the first call to write, what's going to happen is that next time you call write for the second time, it will see that there is an error stored and it will do nothing. Right? So it lets you write concise code while still like being fair about error checking all the time. Right? So again, I like this. So 7, because errors are values, we can make table-driven tests. So I have a friend from Brazil that, so back in Brazil, I used to do coding dojos. It basically means that we used to meet every week to do some coding together. And this friend, he was all the time, we write some TDD, some piece of test. He's asking me, like, let's write table-driven tests. Like he was very focused on logic programming, and that's not my case, but apparently for him, it was really reasonable to think about test cases as a table. So maybe I try to think that as like build a Excel spreadsheet, right, about all the test cases and the expected outcomes. And imagine like in Excel, you could do that, right? You could like put the inputs in some columns, the output in another column, compute the system output, and then just compare like the expected with the actual value. So he was all the time asking me, can we do that? And we used to use a lot of Python and Ruby and like JavaScript and other languages. We were normally varying the languages. But we were normally attaching to the rule of that there should be only a single assertion per test method. So who here has heard that idea, right? So whenever you write a test method, keep only one assertion. And why is that? Is that because the way the test framework works is that it uses exceptions to notify the state. So it uses exceptions to say, oh, the test failed. And when you raise an exception, you can't you can't really continue where you were, right? So if you have multiple assertions on one method, the first one that fails, you never see the result of the next. So that's where the idea of splitting it comes from. So in Go, it's pretty easy to write table-driven tests, and it's also very common. You find it a lot in the standard library and in other Go projects you see. So this I took from the standard library, which I thought was a reasonable example to think about. So this is a function that converts, it parses a string and returns an integer. So in C, it's called this A to I. And the way that we define tests, we just say that there is a struct, and here we tell what are like the columns for input, right? So the input is a string, and we say that the output would be an integer. And then there is also some other output, which is an error. That's because when you're parsing the string into a number, you get actually two outputs. So in Go, you can have multiple return values. Right? So the first one is a number, if it succeeded, and an error if you can parse that string. So again, no exceptions, you get an error as a return value. And then the test cases are just this, this table here, right? You have, here's the input, here's the out, here's the error. Input, out, error, input, out, error. There are like hundreds of these. I cropped it, took some. So if it was like, if each of these cases were a method, you have like a lot more lines of code just repeating, you know, the test and having to give test names for each of these cases. It's probably unnecessary, right? Having a test name here is not really relevant, I'd say. So then you have a single test function that will test all of them by iterating over the tests, and then it tries to parse from input using base 10, and it gets the output and error, and then it compares if the output you expected is the same as what you got, if the error you expected is the same as what you got. If not, just print a message. So again, this is just like normal language stuff. There's nothing special. The T is an argument. Here you're calling a method. When you call error, what it does, it just notifies the T, which is part of the testing framework, that there was a failure there. And it keeps going. You're automatically on the next iteration of the for loop. It doesn't explode your code, right? It keeps going. So this is why like the errors being just normal values make it easy to write a test that tests multiple inputs or multiple cases with a single implementation. Oh, wow. That's fine, okay. So last one. Last one is actually part of what Aaron will talk. It'll be the last talk today. I just wanted to give a bit of my feeling like why interfaces are really cool. So later on, like we'll see like how we think interfaces are cool if we agree, right? We'll see. So for me, interfaces in Go are a cool feature because I always wanted to write them in Python, and there's no such thing as interfaces in Python, right? So in Python we have, like you hear about duck typing, right? It's part of Aaron's talk. It's called duck. So when I was writing Python code, sometimes I wanted to tell the compiler or tell the interpreter that, hey, I want this thing here to have a certain, to be able to call a certain method on this certain thing. And the way you do it in Python is just say like, yeah, like just call it and see if it works, it works. If it quacks, then if it quacks like a duck and walks like a duck, then it's a duck. So, but then like you have to go and write maybe like unit tests, testing that you don't pass invalid input and like a lot of these things. And I really miss, actually maybe I miss some type checking from compiler or some, like the interpreter being more helpful to me and saying, hey, this is it. Or maybe sometimes for documentation. What happened to me in Python for documenting that something is expected to have certain methods is to create like a class, right? and say, hey, here are the methods, and maybe you put not implemented, like raise an exception in each method. That's the way to guarantee that something has certain methods. But in Go, you can do this. You can tell the compiler that, hey, I want something that implements these methods. The inputs are these types. The outputs are these types. This is great. So, so the other thing that comes to mind in Java, you have interfaces, and I think this is maybe how interfaces work for most other languages. Is that interfaces you have to you create a class and you say this class implements certain interface. So in Go there are no classes, so there would be something for after the talk. But there are methods, and the cool thing about the interfaces in Go is that you don't have to declare them. Right? So where in Java you have to say, hey, here's my class, it implements this interface. This works if the interface is in some library or in somebody else's code. But if you want your code that you just wrote now to implement, sorry, you can make your code implement somebody else's interface, but you cannot make, so yeah, again, this is confusing. Yeah, so if you declare an interface, you can't expect your caller's code, right, a third-party code, to implement your interface. So you can implement somebody else's interface. You cannot have them implement your interface. Does that make sense? It's a bit tricky on the wording. So yeah, so as I said, like in Go, the interfaces are explicitly satisfiable. So if the method is there, it implements the interface. So it's much like the duck typing, but it's checked by the compiler. And here are just like examples of 4 very common interfaces that come from the standard library, and you might end up implementing or using things that implement them. One is IO reader, IO writer, the thumped stringer, and the empty interface. So the example of, whoa, this is crazy. You just go all the way forward. So the example here, to implement the reader interface, you just say that it has a method read. Whoa. Okay. So let's do it hand. So the reader, you just say that it has a method read that takes a slice of bytes as input and returns an integer and an error. So if you see anywhere a function that is called read that has that signature, it will automatically implement a reader. And whatever code expects a reader, you can give this thing you have in at your hand. Then the important thing about interfaces is to keep them small. Again, this is maybe cultural. If you come from other languages, you have like Java with gigantic interfaces, and then you see like if you want to implement some interface, but it doesn't really make sense to implement all the methods, then it becomes one of those runtime exceptions not implemented there or something like this, right? So in Go, the idea is completely reverse. It's to say keep the interfaces really small. So I showed you 4 interfaces here, and each of the first 3 have 3 methods. Sorry, 1 method in each, and the other one has 0 methods. So it's funny to say that like the average number of methods in an interface for the most common interface is 2/3. Right? So like there's less than 1 method in an interface. And if you have small interfaces, you can go and compose them. So here's an example of how to make a read writer, which is both a reader and a writer. You can put interfaces inside of interfaces. So if you need something that can read and can write, you use a read writer. It's also common to have, for example, something that can read and can close. So you create a read closer. So I find this really nice way to compose code. So here I have some sample code of how you would go and actually implement interfaces. So I already said this, so here it serves as a way to see. I'll try to click again on the on this and see what happens. Yeah. So you have basically here a struct. I call it file. It has a name, right? You can think this is a class. It's not a class. It's just a struct type. Again, random fact. You can implement methods in any type in Go, not only structs. So any type, like a number or a string, you can put methods there, which means that all of these things can implement interfaces. Right? So it's a different way to think about how you organize your code. So because file has a method read that satisfies that the signature in the interface, this automatically implements that interface, and I didn't have to write it anywhere. Same for write, same for string. So there's nothing more to it. And if you define your own interface, you just again say what is the signature of the method that you expect, and anything that implements this interface, anything that has this method automatically implements your interface. And I have here a really cool hack that I came across these days. This was in the Go source code. Somebody discovered that the Go tool had a dependency on both an HTTP server and an HTTP client, and it didn't make sense that like a binary tool had a HTTP server in it, and then the solution was a really tricky replacement. Like I don't have the diff here, just the final solution. So again, I'm not going to explain the whole thing, but the trick was to declare an interface within a method. So you can see that you can declare a type anywhere, and it's only within the scope of this function, of this method, right? So you say that you have an interface that is request to large, just because you want to call request to large in some value that you have at your hand. And you do like a type assertion here. You check that the thing you have, the L.W, is a request to larger because it has that method, and then you can use it. So I find this like really cool thing that it's really like the duck typing that we think of. And you don't have to like declare an interface like ahead of time. You just use it. You just declare it when you need to use it, and you're done. So, yeah.
Can you
Uh-huh.
method request to large doesn't have to be with capital R if it was pulled from a different package?
So this is from the same package, right? So the lowercase r and uppercase r would be different methods. So this must be on the same package net HTTP.
Yeah. Do I understand it correctly? It was the previous implementation of this method. It didn't have the interface, right?
Yeah, no. It didn't have the interface. It checked for a specific, it was a response type, I remember now. So there was a response type, which is also declared on the same package, but the response type, in the end, like for transitive dependencies, it brings in the HTTP server, which was not necessary. When you do this, basically you don't need to talk about response, so you don't need to talk about the specific type, but just about the method that you're interested in. So it removes the transitive dependency.
If it was declared in the same package, now I understand.
Cool. So just to recap the things I talked about. So the features I can leave without. Simplicity, that's by far the most important. Then single dispatch, capitalization, Go thumbed, Go doc, no exceptions, table-driven tests, and interfaces. I had other things in my head that might be another talk another day for another 8 things that are also interesting in Go. So yeah, maybe next time. And the last thing, if I still have time, I wanted to mention is that if you're really interested in Go and you want to practice it, we are actually doing since January regular meetings every Wednesday from 6 to 8. It's the Coding Dojo Brno. There is a link here. I might post some information on the meetup page as well. This is basically a hands-on meeting that like a group of people get together and we practice pair programming and test-driven development. And we've been using Go for all the meetings we're doing. So it's a chance for you to get familiar with Go in a hands-on practice. So yeah, thank you very much. Don't know if we have more time for questions or not. So yeah, thanks.